Okay? So we're going to start with some of the stuff we did. How many of you guys remember how to do, didn't we do this the other day? 3 plus root 2 times 4 minus root 7? Did we do that? Was it on your homework? Okay, well there's some more today. So let's make sure we know how to do it. Okay, once again we're going to go ahead and distribute through, correct? Okay, 3 times the 4, 12. Put this up. Hi everybody. 3 times negative 7, root 7, excuse me, negative 3 root 7. That's what I did. Root 2 times 4 plus 4 root 2. Root 2 times a negative root 7. Negative root 14. Remember, if they are like bases, we can go ahead and multiply underneath, can't we? Right? Not like bases, I should say like radicals, right? Is this done? It is. There's nothing that combines. So notice this is root 7, root 14, and root 2, root 14, right? None of those are the same. None of them can simplify, so therefore that is my finalized answer. Hi, sir. Recording. Yep. Any questions on that guy? You guys all feel good? On him, we all question him, don't we? Mr. Atkinson. Crazy. Hi. I usually like my real number, not my real number, my rational number first. Usually that happens. But to be honest, it really doesn't matter. Uh-oh. Any of you guys remember how to do the next page? Yeah. I remember now. It's been many moons, people. Okay, what if I had the cube root of 4x cubed y over the cube root of 32x to the 5th? Let's look at him. Okay. Do they have like radicals? First question, do they? So if they do, what can we do? Simplify first, correct? Can I simplify anything? Can the 4 and the 32 simplify? What do they both share? 4. So this becomes cube root. Okay, 4 and 32 both share 4, so therefore that's a 1 on top and an 8 down here now, correct? Everybody there with me? Okay, how about the x's? Can they reduce? I got x cubed on top, x to the 5th on the bottom. So remember, like bases, we go ahead and subtract. So therefore there's going to be 2. And is that upstairs or downstairs? Downstairs. Okay. And is there any y's to simplify? So he's still just a y up on top, right? Is that my answer? That is simplified, but is it simplified mathematically? Once again, do we like radicals in our denominator? Okay, so anytime I have a number, I personally, Mr. BJ Roberts, I break it down. 2 and 4, 2 and 2. Ooh, group of 2, 3, because it's a cube root. We like that, don't we? Okay, how about the x's though? How many more does he need? 1 more, because I have x squared and I need a group of 3, don't I? So therefore I'm multiplying by the cube root of x, top and bottom. Okay, I don't think she has the page extender button. So this comes over here to be the cube root of xy, right? Okay, cube root of 8 was 2. Now I have the cube root of x cubed, don't I? Which is just x. That would be it. Same radical. Simplify, yep. If they don't, get them to be the same radical. Okay, and I'll explain that in just a minute. And then simplify and then go from there. Okay, Miss Rowley, you're good now? Okay. Okay. This? Oh, right there. Okay. Now, how many of you guys remember... Does anybody remember doing this? I don't think I've explained it, but has anybody ever simplified a fraction with a radical in it? That is not just one radical, but a binomial. Anybody remember what you do? No? That's good, because you haven't learned it. Ha-ha! I showed you yesterday. That's cheating. Okay, so what are we going to times top and bottom? Ladies and gentlemen, this is where conjugates come in. What have we ever noticed about conjugates? The middle terms, what do they happen? They'll always cancel out on conjugates, won't they? Okay, that's why we do them. So therefore, if I want to get rid of the radicals, because what's root 2 times root 2? That becomes a whole number, doesn't it? Okay, let's go ahead and just distribute top and bottom really quick. So I got 12 plus 3 root 2. That's just me multiplying the tops together, correct? The bottoms, here we go. 4 times 4 is 16. Then we got a 4 root 2 minus 4 root 2. Uh-oh, we're going off the board here. Minus 2. Okay, so the top still stays the top. 12 plus 3 root 2. What does the bottom become? 14, because 16 minus 2, because the inner terms of our distribution will cancel out, because that's what conjugates do, right? They get rid of the middle terms. Okay, so we have 14. Is that my answer? This would give you 3 out of 4 points on a test. What do they all have in common? Miss Summers. So these guys all have that, and so therefore, oh, they don't all have anything. That is simplified, silly rabbit. Thank you, ma'am. Have a good day. If that would have been a 2 right there, then we're good to go. Oh, sorry. That's mine, actually. Okay, so I cannot simplify. I thought I had it. But I was thinking this was a number that 14's in common as well. But it's 12, 3, and 14. So do they all have something in common? No, they don't. Okay. Now, just be aware, what if they asked you on your homework to simplify it and put them in fractions? Then this would be 6/7 plus 3 root 2 over 7 as well. That could be not 7, but 14. I prefer this answer, but I'm just trying to remember what they prefer. I can check a little bit later. Everybody good there? I just divide it. 12 divided by 7 is 6/7. 3 root 2 divided by 14 is 3 root 2 divided by 14, right? I prefer this. I just saying I can't remember exactly how they have it. Does that make sense? Okay. Now, we're going to do a lesson here that a little bit tricky. Not really, but understand here. Can I go ahead and ask you guys, what's the square root of 64? It's just 8, right? If I asked you what is x squared equals 64, what do we do there? We just take the square root, but we do plus or minus square root of 64, which is plus or minus 8. Okay? So when we take just a pure simplification of root 64, that's just 8, right? But when we physically take the radical, then we need to go ahead and put our plus or minus. Does that make sense? Okay, but variables, we don't always know what they are. So for example, if I asked you, what is the square root of x squared? What do you guys think? X. That seems reasonable. Okay? But do I know what that value of x is? So what happens is that if that's negative, because how many of you guys understand this? The other reason here is if we have 8 squared, doesn't a square root and a squared get rid of each other? So that becomes 8. A squared and a square root get rid of each other. So that's another. You get what I'm saying? But I don't know what that variable is. Correct? Because I don't know what that variable is, and he came out as an odd power. Notice he came out of an even root, odd power. I need to put absolute values around him. What that does is then that makes sure that our answer is going to be 8, like in this case. We didn't know which one it was. Square root of 64, or 64, do we know if that's negative 8 squared or 8 squared? We don't, so therefore it's just 8. Does that make sense? But here, we don't know what that value of x is, so therefore we put absolute values around it. Exactly. So now, whether we don't know what it is, but by taking the absolute value of it, does it ever matter? Because it'll always come out just to be x in general, won't it? Okay, does that make sense? So let's try another one. Okay, so if I gave you the square root of 125 x to the 5th, y to the 7th, okay? And I ask you to simplify this. Once again, we're looking for groups of 2 because it is a square root, correct? Okay, so we're going to break down the 25, 125. What's in 125? 5 and 25. Okay, we are looking for groups of 2. There's my group of 2, huh? He gets to come out. What about the other guy? Because this other guy didn't have a buddy, did he? This 5 didn't have a buddy. So therefore, he has to stay in. Correct? Okay, let's go to the x's. How many groups of 2 are in x to the 5th? There is 2 groups of 2 with 1 left over. 2 groups of 2, hence x squared. Notice if I showed that, that's x, 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 correct? So notice there's a group of 2, there's a group of 2, hence why x times x is x squared on the outside, right? 1 left over. But if we had x to the 100th, would you guys like to write out 100 x's and start grouping them? No, so let's look into easier ways, which basically it's division, right? How many times can 2 go into 5? Twice with 1 left over. Does that make sense? If I wrote this as a radical, wouldn't that be x to the 5 halves, which is x to the 2 1/2, or x squared times x to the half? You get what I'm saying? Hence why he gets come out, and this guy's still underneath the radical as well. I think you guys all get this now, right? Feel comfy? I just killed it. Basically, kicked the dog while he was down. Don't kick dogs while they're down. Exactly. Don't do it. Okay. How many groups of 2 are in y to the 7th? 3 with 1 left over, right? Is this my answer? I'd give you 3 out of 4 if this was a 4-pointer question. What are we missing? We just barely talked about it. On which one? Do I need the x? I'll explain why the x doesn't need it. Anything squared comes out to be what? So it doesn't matter what that x value is. Anytime I square him, he comes out positive anyway, right? This is the guy I need. Okay? The y to the 3rd is the one I need to do absolute value. My rule, once again, what did I say? I don't know if you guys heard it. Even root, if you're coming out of an even root, and on the outside you get an odd power, even root, odd power. It's like a little chant to me. I say it in my head all the time. Even root, odd power, even root, odd power. Those guys are the ones that get absolute value. Exactly. Because once again, we don't know the value of that, so it could be negative, right? Cube root, does that matter? Because can a cube root have a negative underneath him? It's okay, right? That's why it's only on even roots. Make sense? Doesn't matter. Nope. On the outside, we don't care about them because anything even on the outside will always be positive anyway. Even powers. Okay? Let's do another one. So if I had the cube root of 32, x to the 8th, y to the 15th. Okay? Break down the 32, right? We're looking for groups of 3, aren't we? Okay? 32 is 8 and 4, 2 and 2, 2 and 4, 2 and 2. There's a group of 3. He gets to come out, doesn't he? What about these two 2s? What do they have to do? Stay in, so that's 4 on the inside, isn't it? Okay? Now, once again, we don't have to do 8 x's, do we? We don't need to do that because we can say to ourselves, self, how many times can 3 go into 8? Twice with 2 remaining. Right? Trevor, you good? So once again, I went to the x's. How many groups of 2 or groups of 3, excuse me, how many groups of 3 are in 8? How many groups of 3 are in 8? 2, hence the x squared, right? How many's left over? 2. Make sense? How many groups of 3 are in 15? Is there any left over? So the y to the 5th comes out, and there it is. Now, am I done? Do I need absolute values? I do not. Is this an even root? It is not an even root, so therefore it does not need to take care of it. Why? That's what you asked, right, Peyton? Okay, think about it. Is it okay to be the cube root of negative 8? Yeah, what is the cube root of negative 8? That's fine. It's nothing wrong with being a negative number on a cube or an odd root. Right? On an even root, does it make sense? No. Okay, that's where the absolute value comes in. So we're going back to our previous question, correct? So you're asking once again, why does it matter on the y's here? Okay, you're asking on the y's instead of the x's, correct? Okay, it came out even from an even root, right here, even root, correct? He did come out odd powered. It has to be at both cases. So therefore, on this other problem that we did, notice it was an odd root, then we don't care. With me? This would be the finalized answer. So the key thing you got to be, the trick on the test is going to be, what did you get? Yes. Okay. So, once again, even root, odd powers. That's what you're going to look for your absolute values, please, okay? Awesome sauce. Okay, you guys ready for another one? What is this? Whoa, Betsy. Whoa. That was my horse growing up. Her name was Betsy. She died because she ate too many apples. Seriously. She foundered. Okay, here we go. What is the square root of 7 times the 9th root of 7? Ooh. I'm going to push pause for a moment. Work on it. We're back. Okay? So, Trevor, once again, what does this square root of 7 need to raise to? 7 to the half. Remember, this is a square root, so please understand that. Okay? Now what? This guy becomes 7 to the 1/9. Now they are like bases. When you multiply like bases, what can you do to their exponents? Add them. Good job, Miss Monroy. So this is 7 to the 1/2 plus 1/9. Am I saying your name wrong? Okay. No, ma'am. Just like here, if I had x squared times x to the 3rd, what would that become? We don't say x squared to the 5th, right? Does that make sense? So think about very basic rules, and that can help you sometimes as well. Okay? Sid, do you have a question? Okay. So once again, is this something I can do? I need to get them to be like bases or like denominators, common denominator. Right? We all know Arnold's playing around here. So that's 7 to the 9/18 plus 2/18, which is 7 to the 11/18. Now notice, usually if they start in radical form, what do they want to end in? Radical form. So this is the 18th root of 7 to the 11. Miss Monroy. Okay, once again, going back to here. X squared times x to the 3rd. Do I say that's x squared to the 5th? I don't. I say that's just x to the 5th, right? Because they are like bases, I can add the exponents. Does that make sense?
They always have to be like
yes. Okay, now, that one was pretty simple, right? Not too hard. You just had to remember to go radical to exponential, right? That is a thing that you're going to have to flip-flop sometimes throughout this unit, is going exponential to radical, radical to exponential, vice versa. Okay? So please, please, please always make sure of that. Gabe, you got a question? Okay. So now let's go to this guy. What's the cube root of x squared times the 4th root of y to the 3rd? I want them underneath one radical. Once again, want them as one radical. Are they the same radical? So can I multiply these guys yet? No. So where does the cube root and the 4th root meet up? The 12th root, right? Does that make sense to everybody? So either I can make him x to the 2/3 and y to the 3/4. Okay, that looks like a horrible 4. And I go ahead and say, okay, this guy needs a 4 and a 4. This guy needs a 3 and a 3. So this is x to the 8/12 times y to the 9/12. Are they like bases? Can I add their exponents? No, because they're not like bases. But, I think it's this button right here, somebody said. Ooh, I'm scrolling. Okay, let's go back to radical now. 12th root of x to the 8th. 12th root of y to the 9th. Now can I multiply them because they are like radicals? If I was cube root of 3 times the cube root of 9, I could say that's the cube root of 27 because they are like radicals, and I can multiply underneath, can't I? Now they are like radicals. I can go ahead and multiply those two together to say that is the 12th root of x to the 8th y to the 9th. Okay? Can I show you a different way to do it instead of going to exponential? It's very similar. Didn't we start out as cube root of x squared, right? And times the 4th root of y cubed. Okay, once again, I just want the radicals to be the same. So I'm going to 4 and 4, 3 and 3. Does that make sense? Get them the same. So that's the 12th root of x to the 8th times the 12th root of y to the 9th. I just got rid of the middle step of going to exponential. If I could understand this radical still is a fraction, and I have to do it to both things outside the radical and inside the radical, I can just treat it like a fraction, right? The radical to be the same. So therefore, this is the 12th root of x to the 8th, y to the 9th. Get the radicals to be. Always the radical, because that's your denominator, right? If we're thinking about it, that is our denominator of our fraction, correct? Okay. You're going to push pause. On your homework, sometimes they're going to assume all variables are positive. If that's the case, do I need absolute values? I don't. Okay? I don't need to care about absolute values if they're telling me that the variables are positive. Right? Because that's what the absolute values is doing, is avoiding the negative variables, correct? So I think there's only like 3 of them that you're going to have to do absolute values with. Well, not even necessarily that, but like when we were doing it a couple of examples ago. Okay? 26 problems. They're pretty fast, though. Okay? You guys ready to rock and roll? Let me see if I can find some carts. Maybe we can work on them today. Okay? Feel good?